So we're going to look at part 2 of the test review, question number 8. We want to look at that bar graph here and we want to figure out which statement is not true. So we're going to keep going over all the answer choices until we come to one that is false. So if I look at answer choice A, it says Barry Bonds hit more than double the number of home runs that Joe DiMaggio hit. So if I look at my graph, Barry Bonds is way up here at about 750 and Joe DiMaggio is right here at about 350. Double means times 2, so if I take 350 and multiply it by 2, I get 700, and I can see that 750 is more than 700. So A is a true statement. We're looking for one that is not supported. So I'm going to look at letter F. Mickey Mantle hit twice as many home runs as Joe DiMaggio. So Mickey Mantle right here is a little above 500. We're going to call him 525. And once again, Joe DiMaggio is 350, and he's right here. So if I multiply 350 by 2, I get 700, and I can see that this number right here is not twice this number. So B looks like it's not supported, but let's keep going through the answer choices, making sure that we didn't make a mistake. So C says the difference in the number of home runs hit by Sammy Sosa and Rafael is approximately 50. So if I look at Sammy Sosa right here, he's a little above 600. We're going to call him about 610 or so. And then Rafael is right here in between 500 and 600. He looks maybe 550-ish, 560-ish. Difference means to subtract those two numbers. So change that to a 610. So the difference between those is about 50, and I can tell that from the graph. So C looks like it's a true statement here so far. So let's go to letter D. Letter D says Jeff Bagwell hit less than 1/3 the number of home runs hit by Sammy Sosa, Alex Rodriguez, and Ken Griffey combined. So Jeff Bagwell, if we look at the graph right here, he's at about 450. And we need to take Sammy Sosa, Alex Rodriguez, and Ken Griffey and combine them. So Sammy Sosa is right here. Let's round that just to make our numbers a little bit easier to work with. Let's go with about 600. Alex Rodriguez is here at about roughly 600. And then Ken Griffey is right here. He's a little over 600 as well. But let's make our numbers nice to work with here. When I add all three of those together, we're just going to get an estimate. So they hit about 1,800 together. Well, 1/3 means that I can either set up a proportion and get 1/3 of 1,800, or I can take 1,800 and I can divide it by 3. Either method that I choose, the proportion or just dividing by 3, I get 600, and I can see that Jeff Bagwell is less than 600, and it says the word less right here, so that is a true statement. So our answer is B. So let's look at number 9. We want to go through those answer choices, and we want to look at what conclusion we can make. So letter A says about 50% of the sample temperatures for city A are between 30 and 43. So if I look right here between 30 and 43, once again, from my minimum, if I draw a box and whisker plot here, each one of these sections represents 25%. So from my minimum to my Q1, that's only 25%. So I can see that A, since it says 50%, is not correct. So I want to look at B. The IQR for city A is greater than for city B. Remember, IQR is the distance from quartile 1 to quartile 3. So for city A, we're going from 43 to 70. So if I take 43 and I subtract it from 70, I get 27. And for city B, I'm going from 52 to 79. So 79 minus 52 is 27. Answer choice B says it's greater for city A. Well, I can see right here that they're the same. So let's go to answer choice C. The range for city A is the same as the range for city B. Remember, range is the distance from the minimum number to the maximum number. So for city A, we go from 30 to 89. So I'm going to subtract those, and I get a difference of 59. And for city B, I'm going to go from 41 to 90. So I'm going to subtract those. And I get 49. And it says that they're the same. I can see right here that they're not. So let's look at letter D. About 50% of the sample temperatures for city A are between 43 and 70. Well, 43 is at Q1 and 70 is at Q3. Well, remember Q1 is from here and Q3 is here. So between these two lines, that's a total of 25 plus 25, so 50%. That's looking pretty good so far. And then for city B, 50% of the data is between 52 and 79. So 52 goes from Q1 and 79 is Q3, so that is 50% of my data. So that is answer choice D for number 9. So number 10, we have a circle graph here. Which statement is best supported by the graph? So we're looking for something that is true. So A says fewer people prefer horror movies than those who prefer romance and science fiction combined. So I can see right here, horror movies is 25%. Romance and science fiction combined. Well, romance is 5%. Science fiction right here is 15%. And when I combine those two, I get 20%. It says fewer people prefer horror. Well, I can see that the percent for horror is actually bigger than the percent for romance and science, so that's not a true statement. B says exactly 20 people prefer family movies. So I look at family movies and I see that I have 20%. So I'm going to set up a proportion. Percent over 100. And I need to know how many people that would be out of. I look up here and I see they surveyed 360 people. So if I cross multiply, I get 7,200. And I divide by 100. And I get 72 people. I can see right here that that is not a match, so I get rid of answer choice B. C says the number of people who prefer comedy is 120. So comedy is 35%. So once again, percent over 100. And I want to know how many people that would be out of the 360 that were surveyed. So I'm going to cross multiply here, and that gives me 12,600, and I divide by 100, and I get 126 people. I can see that those two are not a match, so I get rid of answer choice C, and I double check D just to make sure I didn't make a mistake somewhere. 36 more people prefer comedy movies than horror movies. So comedy movies is 35%. Horror movies is 25%. So the difference between those is 10%. So I'm going to see if 10% is equivalent to 36 people. So percent over 100 and X over the 360 people that were surveyed. So I cross multiply. That gives me 3,600. I divide by 100 and I see that gives me 36. Another way that I could have worked this problem is I could have taken each one of these percents and I could have set up proportions. And here's horror, 25 over 100 and X over 360. I could have solved for both of those values for X, and then I could have subtracted my values for X. Either way, I'm still going to get 36. So the answer is D. Okay, so the next question, letter A, how many times greater were the ticket sales in 2010 compared to 2006? Well, I can see from my bar graph here that in 2006 I had 100, and in 2010, come over to my bar graph and I have 250. So if I divide 250 by 100, I get 2 decimal points. and bring down my 0, I get 2.5. So it is 2.5 times greater in 2010 compared to 2006. So then question B says, which of the following statements is not a valid conclusion? Circle all that apply. So it's possible that we could get more than one answer here. So part 1, the change in the number of tickets sold from 2006 to 2007 is twice as much as the change in the number of tickets sold from 2009 to 2010. So 2006 to 2007, I can see right here that I don't have information for 2007, so I need to look over here at my table. So I'm going from 100 in 2006 to 150 in 2007, so that's a change of 50. And then I look at 2009. There's no information in my bar graph, so I'm going to look at my table. That's a change, or that's 200 people for 2009. And for 2010, that's 250 people. So that is a change of 50. According to this statement, those numbers should be twice, and they're not. So that is not a valid conclusion there. So we're looking for ones that are not a valid conclusion. So statement number 1 is not a valid conclusion. So then we look at number 2. The number of tickets sold in 2008 was less than the number of tickets sold in 2006 and 2007 combined. So 2008 I can see is 200 people. And then we're going to combine 2006 and 2007. So 2006 had 100 people. 2007 had 150 people. So when I combine those, I get 250. And this right here says that 2008 was less than this number right here. I can see that is a true statement. I'm looking for one that is not true. So I'm getting rid of that. Number 3, the number of tickets sold in 2008 was 80% of the number of tickets sold in 2010. So I'm going to set up a proportion, percent over 100, and I'm going to just figure out what 80% of the number of tickets in 2010 was. Well, 2010 was 250 people. So when I cross multiply and divide, I get a value of 200. And I can see that in 2008 had a value of 200. So that is a true statement. We're looking for one that is not true. So I'm going to get rid of that one right there. And then statement number 4, the number of tickets sold in 2006, which we know from our bar graph here is 100, is almost 50% greater than the number of tickets sold in 2007. Well, 2007 was 150. Well, it says that 2006 is almost 50% greater than 2007. 100 is not greater than 150. So that's a false statement, and I'm looking for ones that are not valid. So I see right there that I have another statement that's not valid. So statement numbers 1 and 4 are not valid statements.